out afterwards, so we hope you can all complete it. Let us know how we did and what other great programs you're interested in. And if you feel free, turn on your video and also put questions in the chat. And at the end, you can unmute yourself as well. I'm going to introduce John Stewart, our Executive Director of MBUS. Thank you, John.
Thank you, Ivy, and welcome everyone. I'm so glad to have you here at MBUS with us. I wish you were here in person and that were something possible, but MBUS is a kind of collider. We call it a place where people come and go and they share ideas and they are wowed by each other's imaginations, and new things are invented here all the time. One of the ways we do that is through 3D printing. And I just want to give you a kind of an overview. About 5 years ago, we got our first group of 3D printers. We bought 30 at the same time. Now we have about 60 3D printers, and we're a place where we encourage anybody to come in and 3D print, as long as they don't print something that they download online. They have to kind of make something, design something, build something, and we're hoping, and we've seen that we're here on Lincoln Road and Washington Avenue, and we've seen that this is a great place for students to come to meet each other from different disciplines, but it's also a place where, as you'll see later, where industry, people from the outside come here and they work with students to create and invent things. And we've had a number of inventions created here. You'll learn more about them. But I should just say that this idea of being able to make something that you need just for your needs is, and you're able to sculpt it and make a part that only you need, is something that's part of the future for all of us. And so we're just here as a basic kind of teaching lab, but we do a lot of work with artists, a lot of work with entrepreneurs. And I actually think that most people at the university, at all in our country and around the world, are going to be in the future using this kind of technology to make things that you can't find at the store. Maybe you don't need the screwdriver that's in the store. You need one that exactly fits your hand. You'd be able to 3D print it at home. Maybe a car part that's not available or something like this is something that you'll in the future be able to print, or a spatula that breaks in your kitchen. All these things are possibilities. Anyway, or maybe, God forbid, you need a body part. That's also something that in the future may be 3D printed. An ear, a nose. This morning I read about a new tongue that even tastes, that you can 3D print. So all that stuff is well beyond our capabilities, but what we are trying to do is to build everybody at FIU that we can to have the platform, to have the understanding of 3D printing, and that's kind of what we're about today. And I work with a terrific group of people here, headed by Jackie Thompson, who is the program manager and who oversees all of the functioning of the 3D printing lab. If you want to come and 3D print anything, you email Jackie and she sets up an appointment for you. Even during these times, we're back to taking appointments with people who want to 3D print. Jackie also works with student technicians, and so we have a couple of amazing student technicians. Diana Vasquez is here, and she'll be talking to you in a bit, and Brett Zerfozo is here too. They're both architecture students, and they're both, but this lab has taken them well beyond the realm of architecture, and they're now printing with artists, they're printing with doctors, they're printing with nurses, and they'll explain to you all the kinds of things that we do. So with that, I'm going to pass the proverbial 3D printed baton, we actually have one, over to Diana, and she'll start the presentation. Thank you for being here.
Thank you, John. Well, welcome everybody. My name is Diana Vasquez, and I am a 3D printing technician. And today I'm going to be talking about some 3D printing basics. So to begin with, if you're completely new to 3D printing, I'm just going to mention what it is. So it pretty much is just an additive fabrication method that uses 3D modeling software. And the most common ones that we have are Rhinoceros 3D and SketchUp. And these objects, I mean, these software can really help you sculpt, like John said, your ideas. And it's sort of like this playing field where you can kind of go wild and do whatever you need to do, and pretty much just sets up the base for the process. And I found this infographic really important because this is just like a basic idea of how it works. And so you come up with your idea. let's say that you need to find a way to display your business cards, right? So you first come up with a design, and then using one of these softwares, whether that be Rhino or SketchUp, you begin sculpting this object. And then what the printer does is that it communicates through an STL file, which stands for stereolithography. And so in that process, your file exports into this file type, and then the 3D printer reads it, and it pretty much just like translates that same idea into a 3D object, such as this one. So, Brett, is there something you would like to add to the?
So hello everybody, my name is Brett. I'm also a student technician here over at MBus. What I'm going to be chiming in today about specifically on this slide is basically kind of how does a 3D printer work? There's been a lot of people probably that if you've maybe never worked with a 3D printer, or if you've done very little bit work, or even if you're advanced, you probably saw like a video on TV or something like that, but I'm going to go a little bit more in depth on actually what it does. In the background right over here, we have, for example, a couple of our 3D printers that we have right over here. Here at the lab, we use MakerBot 3D printers. It's the one of the leading companies in desktop 3D printing manufacturing, and it's one of the more kind of household names that you'll probably find on the internet if you were to Google it. I'm going to take you a little bit through. I'm just going to back up for a little bit of a distance, and I'm going to speak up so you can hear me, but then I'm also going to show you some things that are a little bit more close up to the camera. So for our printers over here, there are the 3D printers are our Replicator 5th generations. They're one of the older 3D printers that we have, and we actually have a lot more newer ones as well. These ones we've been upkeeping and still print perfectly today. As you can probably see in the camera, this 3D printer that I am right next to right over here has a couple different parts. The part right up here, which you might be able to see, is a spool of what we call filament. Filament is basically the plastic that is used to create these 3D models. It's made out of a material called PLA, or polylactic acid. It is a cornstarch-based plastic, so it's it's not exactly 100% eco-friendly, but it's a lot better than most of the thermoplastics that we use for manufacturing today. Then after we go from the filament, there's the control board right on the printer, right in this midsection right over here. There is a little LCD screen that you can use to control the printer, see what file you're printing, how long is it printing for, and so on and so forth. Then you have the bed. There's what is literally a bed, is what we call it. It basically raises or lowers in the Z-axis, meaning up or down, to basically moves it at the height that is needed for whatever 3D print that you have. When it starts very high up because it starts at its initial printing process. And then if you've ever seen time lapses online, you'll probably see the bed move lower and lower and lower and then produce the part that you have right over here. To go in a little bit more, actually I'll take this with me. To go a little bit more in depth on some of the hardware on some of these printers, because we do get a lot of people that do tour here and yes, have seen videos online, but are always curious, how does it exactly work? So to kind of give a little bit of an example, if you think about a hot glue gun, so most people have used it. A hot glue gun is a device that heats up and has a piece of glue or whatever at the end, and then as it moves through the nozzle, it heats up and then deposits the glue or the adhesive material. If you were to take that, if you were to take a hot glue gun and say this is a piece of paper, you take a hot glue gun and draw it in a circle. That's a circle to start off with. That's an example of how our 3D printers work. If you look at the middle slide where it says printer software and slice in layers, what it basically does is that you take your CAD design, your STL, and then you put it into a software that will literally chop it up into like, it can be as little as 10 layers or even 1,000 layers. It's almost like if you take an onion and you were slicing it and you were to look at it kind of from this view, because what it does is that, I don't know, it might be, you can see that there's some of these ridges right over here on this print. What it does is it produces one layer at a time. So for the bottom over here, it produced this outside layer first, and then as the bed moves down, it moves up, and so on and so forth to produce the print. However, we do not use a hot glue gun. We use a little bit more of a specialized equipment, but it's with the same theory. So this is what we call one of our MakerBot smart extruders. It might be a little bit hard to see. I'm going to try to get it as best because it's black, so it doesn't show up 100% the best. So basically what we have is we have our spool of PLA or polylactic acid. This comes in a ton of different colors. You can do white, hot magenta, yellow, anything that you can produce. Basically what you do is that this is a spool. The filament comes as strands of material itself, and then it gets fed into the extruder. This is what's called the extruder, our smart extruder. Basically what it does is it takes in the filament at the top, and then you have a hub gear in the middle that pulls the filament down into the base, and then right at about here on the extruder is where it heats up, and then at the very bottom you have a nozzle which it deposits out of. Now these printers, in order to move, they're essentially almost like robots. You have this extruder that's attached to the printer, and it moves in X and Y. So if you're producing a box, it'll go in a box formation, or a circle, it'll go in a circle formation while it deposits the material out from here. And then as the bed lowers and lowers, it produces more layers, lowers, more layers, lowers, until your 3D print gets done. And now 3D printing can be really used for a ton of different types of things. You don't have to just only make boxes. Like John was saying, you can make things that are very unique to yourself, such as if we had an artist that had a vase, for example, and really needed to have this for maybe an art display or an exhibit that they're doing, but they don't want to go out and try to find something, or it doesn't match the aesthetic that they're doing. You can use this material and this process to create custom pieces all on your own. Now, you don't only have to do that. We've also experimented and have successfully done. We've been able to actually 3D scan some people and even 3D print them. This is myself. I don't know if you can see the resemblance. So with 3D printing, the options are almost endless. You can create anything from vases to faces to mushrooms. You can create whatever your heart desires. And that is basically how a 3D printer works.
To follow with what Brett said, I think that the magic about 3D printing is that you can really find something that's unique to you and customizable. And it really helps just to create and get your ideas out there. So we've done a lot of work with many different people, but I'm just going to go ahead and continue with my presentation. So that was part of the process. So thank you, Brett, for explaining how 3D printers work. We primarily use Rhinoceros, as I was explaining before. So you can come up with your design on this software, and it's always just going to be this language between your printer and your computer, trying to assimilate those two. And you can, it was primarily used for jewelry design because it can go through like a really small, like nanoscale. So it really is used, it started out using for that, but then everybody kind of just started working on different projects on this software. So I think that that's like really amazing, because it's not just limited to like jewelry designers. It really can be anybody that can come in and use this software. We've had, multiple types of people using, so it's really cool. And so we use MakerBot software here. And this is sort of like what the interface looks like to 3D print. And so this is what will, now that you have your STL file, you pretty much just input it on this other software. And then this will, like Brett was saying, it will slice up your design and it'll create it into different layers so that it's readable for your printer. And here you can also customize the settings. So you can make, if you want to make it like really dense, you want to make a really heavy file, you can do that here. If you want to have something that's very light and you need that, it's really just what you want it to be. So if you're making a product, if you're designing something that's really specific, you could use these different techniques from the software itself. So you might ask yourself, like, why would you want to learn how to 3D print, right? What is all the hype about? And I think that the hype is all about, as I said before, is really just about how you can use this to any object, to apply it to anything in your life. It's not just architecture students or designers that use this. It really is available to everybody. And so here we have a summer camp that we hold every year, in which we invite high schoolers and pretty much kids of all ages to 3D print for 4 weeks. It's really something special because they're sort of like the newer generations that are coming up and seeing how this works and see how they can learn to innovate with it. And we recently worked with the Baptist healthcare workers, and we 3D printed over, I don't even know how many shields. Here I have one. So Brett, John.
10,727 as of Monday, I think.
Yes. Yeah, we lost track after so many months. But yeah, it's really been something amazing to be part of. I know that it's really special, the work that we do here. So it's not just, all fun and games. We really do some serious work here too. Then we did this enormous giant mangrove. So that was really cool. Brett spearheaded this project, which he designed all these different parts. And so we made this system to be able to find and put together these pieces. That was really cool. Then I actually have the calf stretcher. So we worked with doctors and nurses to design, to stretch your muscles. So you're a physical therapy student.
Diana, I was just going to jump in. If you have some of those things, the real objects with you, maybe when you finish sharing the screen, when you finish the presentation, you can show them, because people have been asking if they can have you larger on the screen, because now we're all little thumbnails. But if you're showing something, they might like to see it kind of up close, like also with Brett and the extruder.
Yeah. Thank you. I can't see the comments, so thank you for telling me that. Okay, so I'll mention those at the end. And that just wraps up about our presentation for now, about the information. If you can find us on social media, we're there. We're also on Lincoln Road in Washington, so be sure to check us out if you can. And of course, please take the survey. It would really help us out. And there's some really interesting questions on there, so I encourage everybody to check the link. And now I will share the objects with you guys. Okay, so where do we start? We have this is an aorta, well, like not real aorta, but 3D printed aorta that we 3D printed some time ago. And then this was from the summer camp collection. We were working on displaying business cards, so students were actually encouraged to work on their own personal businesses. So this is one designed for business cards.
Can you, the aorta, can you go back? Oh, yeah.
Of course. Yeah, I can go back to the aorta.
No, I thought that was so interesting. This was actually scanned from a body scan, so from like a CAT scan. And we took the CAT scan and and we're able, it's so complex. I think it was hard to make, but we did it for the students at the University of Miami who wanted to see how a catheter would run through this particular person's aorta. So this is someone's aorta. It's not like a oh yeah, there you go, insight. It's not like a random. It's not like a random. It's not a generic aorta. It's a very specific one.
Very specific. It's somebody out there's aorta. So
perfect. Yeah.
Yeah, pretty cool.
Thank you.
Of course.
No, and you were about to show the other card holder. It was very cool.
This is the other one. Very cool. Yeah, we had really interesting students take part in our summer camp, and then going back to the calf stretcher. So these are just all different applications. And they're
so hold it, show people how that works. So if you put it up, it's a half scale model. So you put your heel in the bottom, and it's supposed to push your heel exactly in the right position to stretch the back of your leg. So
yummy.
And they had to, so the only way to test it was to make a 3D print of it before it went into manufacturing. So this is the other thing about this, and this is a great example, is that you can prototype things. Thank you. That's very close up.
I just want you to see the layers of.
Oh, the layers. Yeah, exactly. You can prototype objects, and then maybe the final object is not made in a 3D printed material. Maybe it's actually made in metal or in glass or something else. You can, but to have it in your hand and to be able to see how it works is very important.
Yeah, and essentially like all different types of 3D printers work the same. So it just depends what the input is. So I was watching a video on like body parts and they were 3D printing ears. So they, instead of using they use cells and then they use whatever like bio material that they need.
Right. And we're actually working with we'll be working with Nicholas Health to 3D print toys for children, so that children can understand better their illness or their challenge, and understand it through toys that their parents can kind of play with them. So these can be also very educational in that sense.
Yeah, and this is just like one of the last things. It's a map of Miami Beach that we worked for the lighthouse in Miami. So it actually has it has it in Braille. There's some I can't see. Do you guys see it?
Yep, yeah.
Yes, yeah. So that
If
was
you
another.
hold it a little still. The idea is that perfect is that people who are who don't have vision or don't have full vision have to learn how to walk through cities, and they can't. And regular maps that they can read don't have building heights, so they don't tell you where shade is, or where the sun, where you'll be really hot, or you can find breezes. So this helps them to understand the city and how close or how far they are. Just hold it still for a sec. So there's a part on here that they can. So the other thing I should mention, if you lose your sight, God forbid, and you are, relying on your hearing becomes intensely kind of acute. And so you can snap and you can hear the echo. You use the echo to figure out how far or how close you are to a building, and how tall the building is. But you have to calibrate that somehow. You have to test it. You have to say, okay, that's what a low building sounds like that's far away. This is what a high building sounds like that's close by. And it gives people with this ability a great deal of confidence to walk through the city. And this really helps them to calibrate their echolocation skills. It's quite an exciting possibility. Brett, did you want to say something about this?
Absolutely.
Yeah.
So I have worked on this project just slightly with updating and modifying these projects. I personally have seen what the use of these actually can be for. So the tactile map that Diana has, for example, I have a loved one who is visually impaired and he goes to the Miami Lighthouse for the Blind. This is who we produced it for. One of the activities that they do for their independent living program is they try to get people who are visually impaired that are maybe newly or they're growing older and they need to become a little bit more independent. One of the things that is, in my opinion, one of the most intense and scary things is navigating our urban world around us. Because as we all know, when we're driving, we see street signs, for 16th Street or anything like that. However, if you're blind, you may not know exactly what street you might be traveling down to, so you might have to be using some of these buildings for reference. In their independent living skills program, what they actually do is they take people who are blind and they actually take them around, I believe it's the block around the building of Miami Lighthouse or a couple blocks around, to basically try to train people to use their cane skills and be able to be a little bit more independent when even just walking around for a couple blocks. And then what the ultimate test is that they have you do, and they do this with a trained professional always with you, is that the last step in this is training you to cross 8th Street by yourself. Obviously there would be somebody behind you, but it's training you to learn, okay, which streets are which way am I going and how am I navigating all of this. So this tool is very, very useful. So instead of an instructor telling you go right to go down 16th, you can feel down the map, you can feel on the map and feel, okay, 16th is on the right and 15th is maybe on the left, so I need to turn right. So that's what this can be really, really helpful for.
just like to add something to the tactile model that Diana is showing. We also want to encompass the whole idea of universal design. So the choice of colors on the 3D printed model, we've used the gray to represent the streets, and then of course the buildings and landscape to be represented with the white. And that is because not all visually impaired people may be totally, have lost their sight totally. So some may have some sense of color. So that also gives them a differentiation to see the contrast. So it's like we're trying to make our models be aesthetically correct for anyone who sighted, visually impaired, but as well as functional and useful for those that are 100% without their sight. So we try to encompass in all of our designs the whole concept of universal design. Anyone can use it and take away from the final product. Okay. As looking at one of the questions in the chat, and someone was asking about what's the best printer for multicolor printing. And when you say multicolor printing, it's just a choice of filament that we use. At our lab, we only use PLA, just because we are a product of MakerBot, and we are under warranty with them. And they do have filaments that comes in different colors. So it depends on this, the string that you use. Then it will vary, have variations of color. If you're referring to changing out one color within the same print, the MakerBot does have a 2X machine that you can use 2 extruders at one time and print. However, we don't have that one at our campus here. But yes, exactly like what Brett is doing, it has the two extruders going simultaneously on the product, on the print. In addition to though, we can stop the print in between, take out one filament and load a different color, and continue the process on the same model. So there are different possibilities to get the ultimate goal, if that answers your question.
And I was going to add on to another question I see about 3D printers at the BBC campus. They're definitely, we have a kind of a sister institution called the Radcliffe Institute in AC1, and that has, they have 5 3D printers like ours, but the large ones. And the ones that 3D printed the mangrove, for example. And so you, if you would like, I'll put in the chat Jacek Koleżynski's, Professor Koleżynski's name and email address. Reach out to him. But yes, there are printers on BBC.
Okay. Okay, let me see. And yes, if anyone wants to get more information about your scheduling appointment, please reach out to me. I've put my email address in the chat, and we can set up a printing session if you're not familiar with 3D printing software nor the machines. We'll have Brett or Diana. They're always willing and ready to help you. We can do a virtual tutorial. And, once you get a little bit more apt or you want to come right over, we can make that work. We can make it happen because we're here to make people, we're here to expand the knowledge of 3D printing because this is the way of the future.
There's some questions in the chat regarding buying your own 3D printer. I think that it's really something, there's different budgets, of course, so that's something important to consider. The MakerBots are definitely probably like, a little bit high end just because of their design and all the products available, but they're most likely the like leading printer brand in the market. I would say that Brett has more experience with personal printers, if you want to talk about that.
I can briefly talk about that if that's all right. So here at MBUS, we use the MakerBot 3D printers. MakerBots themselves are pretty good for being very user-friendly, intuitive. The software is very easy to navigate, so you can pop in a model, change the settings and everything like that, and then be able to go to a printer and print with it. The user experience is a little bit more efficient. So I do know that MakerBots, if anybody's looking at them online right now, they are a little bit pricey. I do have a lot of experience with my own personal 3D printers. I have 2 of them in my apartment because I print outside of work. So I have a couple budget 3D printers. I noticed that somebody in the chat was asking about the Creality Ender 3. I'm not going to go into a full length about that, but I have 2 of my printers are Creality machines. They're very, very good budget 3D printers. The only thing that you just got to keep into consideration is that the user experience is going to be a little bit more for people who are willing to tinker with their machines. The Creality Ender 3 and specifically is a very low budget 3D printer. I believe it's going around $200 to $300 right now. However, you can do a lot of things with it. However, the user experience is going to be more if you are willing to get involved in 3D printing and learn how the mechanics of it work and basically kind of become your own technician. The software that you use for it is pretty user intuitive, but there's a lot more settings that if you were to download the software and open it up, it will pop up probably about 150 different settings that you can change. Personally, I like that machine just because I can work with them a little bit easier. But I also love tinkering with things and getting my hands dirty, learning how things work and try to, play around with that. If you're somebody that's going to be wanting to get their own personal 3D printer at their house, I would probably suggest looking either on YouTube or also I just saw in the chat as well, Prusa is also a really good company as well. They're actually, Prusa, a little funny thing, the headbands that we used for the 3D printed face shields were originally developed by Prusa. They're a 3D printing company that 3D prints 3D printers. And they're very good budget 3D printers, and the work experience is really good, and also the quality of their prints is like really phenomenal as well. I just probably personally, because I have had a lot of people ask me this because I guess I'm the go-to person for this at my school for some reason. If you're wanting to get your own 3D printer, go to YouTube and just type in 3D printer reviews. What you'll do is, and just watch a lot of them. How I kind of got into the personal 3D printing space, I watched a whole bunch of reviews because I could tell you, buy a MakerBot, and then maybe you yourself might not find that you personally like MakerBot. Maybe you want to try something else. What my biggest advice to you is do your own research and figure out what do you actually want to do. What are the type of projects that you want to do, because that's going to dictate what type of 3D printer you want to use. Now, just kind of, and personal 3D printers are really good, but we love having the lab, and I love using the lab here at MBUS a lot because if you think about it, if you have one personal 3D printer at home and you're using it for a school project, say it breaks, what are you going to do? We over here at the lab, we have, like John said, we have about 60 3D printers, so that way you can either print multiple things at one time, or you have the option to choose between the different models that we have over here. So my overall, the gist of what I'm saying is, if you have the opportunity, come to MBUS and use the lab. It is very helpful. It is always, even for me as a student, my first go-to place. But if you still are adamant about wanting to get your own personal 3D printer, do the research through YouTube, through forums. Facebook has a lot of 3D printer forums that you can just type in questions and people will spit out an answer to you in like a minute or so. So just do your research, figure out what do you 100% want to do, and that should make your 3D printing experience a lot more easier and on your way to being very creative with it.
There's also a question about if we've worked with animators. Not that I know of, but we have worked with people that want to create like maybe some really like quirky products. We've worked with a lot of artists. We're currently working with 2 artists in Miami from Ulite Arts, Sasha Wurtzel and Felice Groden. So you can, I mean, it depends what you want to do, like what's your end goal and what your product is going to be. So we can pretty much just tailor to anybody else's needs, whether you're animators or designers or whatever profession you're in. Any information about the MMC? We do have 3D printers on that campus, but I think you'd have to contact Mike Bisnet, and he's the he oversees the printing lab over there. So if you it's on the Carta page, I believe. So you can, I'll try to like link it after. And then the program. So really good question. So we use Rhinoceros. It does come at a price. I think it's $175, but you can keep it for life and you don't have to pay those $175 ever again. There's also SketchUp, and I think that one is free. Yeah, there's a free version, but there's also another version that is for students, but you'd have to pay. And I can run through like a really quick Rhino MakerBot workflow if that would be helpful for you guys. Okay, so I'm going to share my.
That sounds good. Hey, before you share your screen, there's a question about Brett showing the. Brett, can you say something so you become big on our screens? Say hi.
This is the head print that we did. We basically 3D scanned it, me going around in 360 degrees, and it scanned it pretty well. You can see a lot of the facial features.
How did you scan it though with a?
So basically what we used was we have a Xbox 360 Connect.
Exactly.
If anybody's very familiar with Xbox or video gaming and stuff like that, the Connect that either you buy with it or comes with it, I can't remember. It is very helpful because it actually has a depth camera in it. So you can actually, it'll project light and actually determine what are the depths, so you can see, what's exactly my facial features on this print itself. And we used I believe it was I can't remember the name of the software, but it's basically you plug in the Connect into the software, and basically what we did was I sat in a swivel chair, Diana or whoever it was held up the Connect, and I just went very slowly in 360 degrees, and then it converted the file into an STL file, and then we just kind of worked from there, just repairing any like little bits that it may have not gotten, and then we were able to 3D print it.
Yeah, it's pretty cool. Like it actually, like I have my hair up right now, but it really gets a lot of detail, the scanning. So this is supposed to be me, and it's really amazing what you can do with this. That's just like my own little bust. Jackie also has her own, printed in her favorite color, yellow. Yes.
You were going to share your screen?
Yes, so I'm ready to go through a really quick workflow. You guys see my screen. So this is Rhino. Rhino Meet Everybody. So okay, there's I know it looks really intimidating, but it's actually super friendly, and you just have like your command bar here, and you can also do some plugins on here for rendering. Like for example, if you're doing animations, you can also render your whatever, like your character, your object. So just some basic commands. Let's say I want to make a box. So you just type in box. And you have, I don't know, you want to make a box that is maybe a 10 by 15. And then, I don't know, 20. So here we have our box. And then let's say you want to make like something really funky and you want to boolean in a couple. So booleaning is pretty much just like a subtracting. You could either subtract or add or couple, like, intersect these different shapes. So the way that we apply it for architecture is pretty much just to design our projects, and it's really helpful because it has like this like 3D. You're now seeing in all these different perspectives, that you're not just stuck to seeing things on a 2D perspective. So let's say that you want to boolean out the sphere and you want to add one on the top. So let's say you want something like this. And so you pick Boolean difference. So that will subtract that shape, right? So now you can see it's gone. But you want to add this one. So let's do Boolean union. And here we have this one. So you add them all together, and now it's all part of your objects. And something really important to mention, and now that we're here, is that in order to 3D print, your object has to be a closed poly surface. If not, if it's open or it has a hole or something, it won't translate. It'll be like an open mesh. So when you're translating it from the Rhino to the MakerBot software or whatever 3D printing software you're using, it's just not going to be able to read your object very well. So sometimes it's just not going to come out, or it's going to look like it's there, but it's really like a ghosted image of what you're doing. So please make sure that if anything that you take away from this presentation is you have to have a closed poly surface or a closed mesh.
So Diana, can I ask you a quick question here? Because if you were going to maybe just how would you go about 3D printing that object that you just made? Because it has certain challenges from the way you made it.
Yeah, so that's another interesting thing to talk about. There's a lot of things to consider. So let's say we're ready to 3D print this, and I'm going to scale this because it's probably going to be too large for our printer. So I'm going to just do it by half. So I'm just going to do this really quickly. Okay, so this seems like something that could fit. And let me just check to see that it fits in our printers. So you can also scale it on the software, but for now we're just going to scale it on here. And so you would go to your file and put export selected. And let's name this, and we're gonna put it on my desktop. And we're gonna make sure that it is a stereolithography, so short for STL. And let's go. Okay. So yeah, now we're just gonna save it. Okay. And then we're gonna open our handy dandy MakerBot print software. And let me check the comments. I know someone had a message. Can you use SolidWorks to 3D print parts? Yes, you can. As long as it's an STL, I'm pretty sure that you're fine to print on anything. Okay, so now that we have our software up, I don't want to update right now. Okay, so this is one of like the larger 3D printers that we have here. It's the Replicator Z18. It can print up to 18 inches in height. So this is a big boys. So we're just gonna use a Replicator Plus, which is one of our newest printers that we have. And we're gonna click, so up here, a new project, I'm gonna click add models, and I'm going to find my STL. So here it is. And then also, I think it's a .3D OBJ, no, .obj. That OBJ also works to 3D print, but you have to be aware of what you're doing. Okay, so that looks really small, right? Give me a second. Okay, this is like too small, so you're gonna click it, and you're gonna make sure that it's in your units, and we want it in inches, so that's, I had it in feet. No, I didn't. Okay. Well, you guys understand. You guys get what I mean. So for now, we're just gonna do it in centimeters because that's the only thing that fits in this box. You're gonna want to print this on a side where there's wherever you have like the most surface area to support, because I can't just, if I could send this to print like this, but it's gonna take more time because what it does is that it creates supports, right? Because like you're gonna have something that needs to support this ball. So you want to find the longest or like the largest surface area to print to have the most amount of support. So here are our settings, and we typically use 10% infill. It really just depends how thick you want it, but 10% is kind of like just a standard. And you definitely want to make sure that you have support, which is the breakaway support. There's some 3D printers that you can like, it dissolves and if you put it in some sort of like solution, which is pretty cool. Because that does take some time to remove. And then we want to arrange our project and put the face, like for example, I would say that the best face to like print this on would be this one. So I'm gonna put this as the bottom, and then it's just gonna flip it. because now it's gonna, it's gonna be supported, and I'm not gonna have to deal with so many supports, because now the amount of supports, I'm gonna generate this one, and then just so that you guys can see the difference between this version of the file and then the one that was vertical. So it seems like everything's ready to go. You can customize this further, but I'm just gonna leave this as is. And then here we're gonna have our estimate. And so like right now, like what the software is doing is pretty much just like layering it and creating, like splitting it up, kind of. I think that's a word. What was it called? Not splitting. Or is it splitting? Brett?
Slicing.
Splicing. Thank you. Yes, splice. Take
Will
some
it show
time.
the supports on it?
Yes, I did. I have this tendency to not add supports because I forget, and I'm also sleep deprived. So that also happens. Make sure to don't forget to add supports. It's happened before. And what your print will do is that it'll print something, but it won't be your object. It's just gonna create this like awful mess, and you don't want to have that. So make sure that you always have supports. Even if you think that you're not going to use this, but like for example, like this file, you don't really need supports for this because everything is, like flat. But still, you should have it anyway. Something like this, you definitely want to have supports, because if not, your file could end up getting warped and things like that. So here you see the process of it getting spliced. And the orange is these are the supports, and then the green is my actual file. So right now you're seeing it in half because I have it like by layer, and here you can slowly see the way that it's being generated. So let's say like, this is how it starts. It has to have like a base and a raft, and then it begins to print like your actual object, and it slowly starts growing up and done. And you can also change the inside. So if you want to have like a different infill pattern, that's also available. So, this takes about 6 hours. It requires not that much filament. And yeah, that's it. So then now you would get this file and you would export it, to your USB. This is the type of file, obviously, for a MakerBot machine to use. And that's it. So we would be able to help you. I think somebody asked if there's a system. Yeah, sorry, John?
I was just going to say, so at the end, can you make it, can you extend it all the way up to the top?
Yeah, for sure. So
Yeah,
this is
so I
what
was just going to say, at the end, when you take it off, you're going to take it off the 3D printer, and you're going to remove all the orange stuff by hand. That's the supports. And you'll scrape it down. And if Jackie's supervising you, you will have to do a very good job of removing the supports, or else they will not be accepted. Because the object can look exactly like that. The supports are designed to come off, to break off. So that's all I want
exactly.
to say.
Yeah, and Jackie is the best. She's quality control here. So if you don't do a good job, she's tough. So yeah.
Can you put it in the middle just to explain? When you said about infill, what is the infill and what does it do? Why do you need infill?
Yeah, so you would need infill because otherwise, like it depends if you want it to be like kind of like really sturdy and really strong and like very durable. Obviously, some of the objects have different weights to them. So the infill is sort of just like the structure within your file, and you want it to be something that's durable, so that you can pick it up and take it along with you. You don't want something that's flimsy and it can break and fall. Some things are very gentle. Sorry, Jackie?
Like the density.
Yeah, the density. So like, look, I don't know if you guys can see, but this is like super, super thin. You have to be really like careful with this because it's kind of like a more fragile object. And it's also printed on one of our neutral filament. So this is a little, different. It doesn't have any color. This is sort of like the standard, filament color. And then this is the white one, which they just add like a white color to it. And yeah, you can see that this is definitely by far like, a little more sturdier than the other one. And yeah, it just comes in, it depends how thick you, like this I can feel, this is maybe a little bit heavier. Obviously you have more objects, but you want something that feels good on your hand. And if you're designing a product, this is really important. Okay, so then now I'm gonna run one with a really weird orientation so that you guys can see the difference. And then I'm gonna pick this one. I'm gonna pick, let's say, for some reason, let me just pick here. And I'm gonna make that the bottom. So you see, this is like really, you know, it's not kind of the most logical way of printing it because you don't have any support. Imagine like I'm really just supporting it based on this one edge, right? So you don't want that. But I'm gonna generate it anyway so you guys can see the amount of support that this would include. So, and this takes time, like taking supports off does take time. So I would recommend that you have the least amount of support because it will also affect the way that your print comes out. It does like leave some sort of like little marks if it's something that's like really welded together in this case. So you got to be careful that you have something that looks good. Let me check the comments meanwhile. Any questions?
At the same time though, if you have a lot of supports and once your print is finished, you can use, the material is good enough, and use light sandpaper and just you're applying the sandpaper and get smooth again. So it's not that it's not being able, you're not able to have a beautiful finish if you have less supports, but you can sand it down. And if anything happens, you can always use materials like spatula, etc., and fill in and make it smooth. PLA is beautiful. It's very, very manageable. You can paint it. You can use markers. You can spray paint it. Watercolors. So it's very durable.
Yes.
User.
Yeah. And Jordan asked a question about the multiple colors. Jackie explained this a little bit earlier where we only have one extruder. So if you want to have, let's say like this blue bracelet, but you want half of it to be pink, you'd have to at some point stop the print, change the filament and put in that new color so that you can have both colors be in it. Can you sew without sewing? I'm not sure what the question is, but you can, I mean, it depends what you're trying to sew. I mean, yeah, I don't know. It is kind of hard, so I wouldn't know if a needle could go through your object. It depends how, like how thin you
Well, I was thinking about that question, and I thought it was the question might have been, could you put two things on the board, on the machine and have the 3D printer kind of connect it? And I don't think our particular MakerBot printers allow that. I think they have to create a raft at the base level. But we have stopped them in the past and put other things kind of inside so that they will be enclosed within them. So it depends on how creative and clever you are with the printing process. I'm not sure exactly whether it can act like a glue gun and kind of glue pieces together. But you can definitely make pieces within pieces.
Yeah, that's true. You can always because it's printing, you go ahead and you put in something. That's something that'd be cool to experiment with and see how, because like it'll, as long as it's kind of flat enough that the printer will still keep going, I think that would work really well. And then another question, do all most architectural maquettes models done with 3D pictures? Some you can. Here, actually, Blender is a really good software to use if you're using like a map and you want to make like a quick overview of your city and you want to take your whatever, like zone your area, you want to make a site plan, you want to make a site model, you could use Blender for that too. And it's really good to see what you're working with, like the scales of the buildings and all that's around you. So yeah, you can use it for that. We've done 3D printed models before, or parts of it as well, where you have like mixed media, where you have some things that are 3D printed, some things are cardboard or whatever you're using. You can use, architectural firms are using it. I'm pretty sure we're really lucky here at FIU to have MBUS and have these like really great facilities that have all these 3D printers available to their students. So it's something that we're really lucky to have. And you are also, we're taught to make hand models still, but we haven't done so because of COVID. So having your own 3D printer is really helpful for that because you're really able to create anything that you want. Are we going to set the supports? You have to set the supports yourself because if not, then you're gonna end up with no supports and you're gonna wanna cry when your print fails, because that is gonna be very tragic. So yeah, you have to make sure that you have your supports and to make sure to have that in your model.
Also,
Okay.
hand making your, sorry
Go
to
ahead.
interrupt. I
No,
was
go
just
ahead.
saying, personally, me and a lot of other people, we like to hand make models a lot because it does give you a better sense of what your project actually is when you can actually physically build it by hand. However, we typically, because also for time's sake, some things to be 3D printed, such as, you know, say if you had a cube, it'd be easier to make that by hand and faster to make that by hand and wait a couple hours for it to 3D print a cube. We typically, in my experience, we would do things that are a little bit more complex or things that we can't physically make by hand. So such as if it's a very curvilinear, or even the model that Diana has right over here, it'd be very
Yeah.
complicated to make that by hand out of wood or out of cardboard or something. So it's a lot easier to 3D print. Or you can have a mix. Personally, like some professors that I have had and myself like kind of a mix in some models of maybe some things 3D printed, but most of it made out of either like wood or chipboard. One of the things that we can make out of like 3D print is maybe some of the stairs, because making stairs by hand is very time consuming. Not a lot of people like to do it, and most of the time a lot of people's stairs don't look 100% the best. So if you're hand making a model, but if you 3D print the stairs for it at the same time, once you get done hand making the model, you can just take the stairs and pop it right in your model.
Yeah, it's really helpful for these sort of shapes that you don't, it will look a lot cleaner if it's all one shape, everything's connected. So you're always striving to have nice looking objects. And just really quick before we end. Oh no, go ahead, Brett. Go ahead.
Sorry, I'm so sorry for interrupting you, Diana.
No.
I just happened to see from Nicole any suggestions for the best paint type to use when coloring 3D printed objects. You can kind of use a different, depends on what your project is. You can, if you want to use like very light colors, you can sometimes use watercolor because it's very thinned out, or you can use a little bit of a thicker paint. What I personally prefer is, and a lot of other people like doing this, is getting a can of spray paint and spray painting it. But no matter what, if you're using spray paint, acrylic paint or whatever, get a can of clear coat. Clear coat is basically going to be a protective layer on the outside of the paint itself. Your car has clear coat. When painting a car, you paint the base color, the regular color, and then the clear coat. The clear coat protects from the paint flaking off. Same thing with 3D printing. I've printed a camera, for example, in white filament, but I wanted it black. So I painted it black, but I put a clear coat because I discovered that if I didn't put the clear coat on, the paint just rubbed right off in my hand. So if you're doing any sort of painting, the quickest I would say spray paint, but no matter what you do, get clear coat. Clear coat typically comes in a spray paint can, and it's pretty cheap.
The only other thing about the final model, yes, you can apply any paint to the surface. The only thing is, we'll say don't leave it in direct sunlight because it will warp. The print will warp.
Yes. Sometimes like the extruders go up to 215 degrees Celsius, so it gets really hot. So if you're in any sort of really hot environment, your print can warp or get misformed. So this is another generated output of the thing I did. This one you can see it's 7 hours, the other one was 6. It requires a little bit more filament just because you have more supports. So that's something to consider. But you can see like it's still, it's just not ideal. It has like a more chances of it failing. That's another thing. Prints fail left and right. So you want to make sure that you have the best print setup as possible so that this doesn't happen. And let me see if there's any more questions. So yeah, this is just a really quick run through of how to do that.
Also, just to kind of interject there on the last part that you were saying about failed 3D prints, everybody here, I just want to say one thing. Failed 3D prints will happen. Even if you have the best 3D printer in the world, it can happen from time to time, but just don't be frustrated about it. I've seen, from working here in the lab, a bunch of students who come in here, 3D print, their stuff fails, and they feel like it's the end of the world. It's not the end of the world. Failed 3D prints is, even in everybody's experience I've seen, is almost essential because you learn from it. You can have, you know, it's not convenient for things to fail, but just don't get really upset if something fails. Try to figure out why did it fail. And then you can start to learn more about 3D printing, something that I personally learned. And before I even worked at this job here at MBUS, when I was just a student in 3D printing, a lot of the stuff that I had failed in the very beginning, but I asked questions. I asked questions to the technicians to figure out why did it fail, or what happened, what could I've maybe done to fix this. And then from there, I kind of took it upon myself and start remembering these things in the future that, you know, okay, maybe the model that Diana just showed isn't the best orientation because it's more likely to fail. Maybe I should orient it in a different way. So failures will happen, but it's not the end of the world. I've had friends that bought 3D printers and for some reason keep having failures, and then they ended up selling the 3D printer and then never want to do it ever again. I don't want anybody here to get discouraged with that. Just, it's always going to be a learning experience. 3D printing isn't 100% perfect, but learning from your mistakes will definitely help improve your possibilities for success.
Yeah, for sure. It's just a matter of trying. So, oh wait, just one last question I want to answer. We don't use soluble material or support, but that is available on the market. I don't know if it's like the best thing. I've never tried it before. The ones that we have here are not soluble, so I don't know if Brett has any knowledge on that.
Some printers can print it. It's more likely PVA supports, basically supports that you can soak in water and the material just dissolves. We don't typically use that because it is mostly used in dual extrusion printers. So the printers that have the 2 extruders, plus also your printer has to be able to be set up to actually print that. Some 3D printers will only print certain things. So you have to do check on that, and whatever material you are printing with, double check on what's the melting point and what do you need to print at. Most 3D printer spools, a filament that you'll get, not typically MakerBot, but most of them will even tell you on the label, print between 210 degrees Celsius and 250 degrees Celsius, so on and so forth. But typically for us, if you set the support settings just right, you shouldn't really have that much of an issue removing them in our experience.
Yeah, that's pretty simple to remove. Maria?
Sometimes it's good to know that piggybacking on Brett and the failures, failed 3D prints, someone's trash is another person's treasure. And we've had our professors that use people's failed prints and made lovely designs. So it's surprising what you know, in terms of your project, it may have failed, but it's always good to have failures because someone else can always use the model.
True.
Very true.
Thank you, Maria, for that. I hope you get to come by sometime at MBUS.
I think we're going to have to wrap this up.
It's just great.
Ivy, are you still with us? I don't know how you end these.
Yeah.
Yes.
She
Thank
is.
you, everybody, for attending, and thank you to our wonderful presenters. Yes, I will end it in a minute. If anyone has more questions, please follow up with the emails that were left in the chat, and you'll receive more information. And please complete the survey. Thank you, everybody.
You